So we're going to look at specifically exponential growth and the sum of that. Essentially, this is a problem-solving question. So we try to summarize the question that was given. It says, which gives you more money? And you have the options to take deal 1, 2, or 3, and you have to decide which of these is. Obviously, if you want the more money, then you choose which gives you most. If you prefer having very little money, whatever your preference is, who cares? But what we're going to do is we're going to try to figure out what the values are at the end of these. So deal 1 says you get $1 on day 1, you get $2 day 2, $3 day 3. So essentially every single day you're getting $1 more, and this is going on for 2 weeks. So first thing we really want to define is 2 weeks is equal to how many units of days, because these are measurements of days. We want to work in the same unit. So this is 14 days of summing up values. Okay, so what we're actually going to do is I'm going to go through each of these. We obviously know it's just going to go 1, 2, 3, 4 up to 14. So I'm going to go into our little Excel sheet here, and we go 1, 2, 3. Okay, and what's great about Excel, instead of me writing all these values out, I can just grab this, and it should go right to 14. 14, excellent. And I want to sum them. So we have a little formula here called equals the sum of. And I just highlight all the stuff above. That way I don't have to type it in the calculator, and we get $105 at the end of 2 weeks. Okay, not bad. It's better than getting nothing, right?
You get more money at the end of deal 2.
Yeah,
in one day.
Most likely.
When you don't, Joey.
Not in one day, but it'll get there.
Squared.
So here.
196.
Oh, at the end of that day.
Okay.
Yes, at the end of that day, you're right.
You said day 1.
So this one,
This is an accident, sorry.
the powers, or sorry, I should say the base of all the powers is changing by day. Right? So again, it's for 2 weeks, but on day 2, it's to the power of 2. Day 3 is to the power of 3. Day 4 to the power of 4. So same idea. We'll make this one will be a little wider. I should have titled what we're doing, but I'm going to say 1. I'm going to say 1 equals 1 to the power of 2. Okay? Calculates it for me. So when I say equals, the formula will actually calculate formulas for me. So I go 2 to the power of 2 gives me 4. Equals 3 to the power of 2. 9. So hopefully it picks up this pattern. We usually do. No, didn't quite do it. So I might have to write them in. Actually, here's a faster way to do this then.
149.
149. Clear content. Clear notes? Maybe not. I don't know. Okay. Instead, what we can do is I can use the information in this one. Okay. I know that these are counting. These are essentially my bases. So this is going to be equal to this guy to the power of 2. So I'm kind of giving you a tutorial in Excel, actually. So if I tell it to go to the power of 2 of that cell, it'll pick up this pattern. Okay. So I say the power of 2 of that cell automatically does 4. So this is a pattern that this guy will pick up. Boom, there we go. And then once we've done that, I can just copy and paste my other formula. So like Joey said, the end of day 14, that makes more money than the other one, right? So up
like
to
100% more money.
Yeah.
No, maybe not 100%.
You're getting, well, actually, in terms of percentages, it's 10 times the amount, roughly.
That's fine, yeah.
That is 1,000. I can't remember what it is in percentages. It gets a little confusing. But anyways, here's our two values.
It's a lot.
10 times the value, a lot more. And then we have our final last one, deal 3. It's a doubling one. And what's actually happening in this one is I'm going to relate it to exponential growth. This is set up like this. Y is equal to our A value times B to the power of X. Okay, so this one's an actual exponential equation. On day 1, we essentially have $1. Okay, and what's going to happen here is we're doubling. So 100% is equal to the value of 1. So growth rate would be like 1 plus whatever the growth rate is as a percentage, right?
Yeah.
And then to the power of something. Well, our growth rate here is essentially 100%. That's what it means to double. So we'd be doing 1 plus 1. So in other words, we're going to be equal to, this one's not really important, but I'll write it anyways. 1 plus 1 is going to give us 2. So that's the idea of doubling to the power of x. This one times anything makes no difference. So our exponential equation here is 2 to the power of x. Okay?
X being whatever day.
Nah, x being whatever day it is. Okay? So at the end of day, or 2 weeks, we're looking at 14 days. We're looking at 2 to the power of 14. So it's going to be a pretty large value. So we're going to do the same stuff we did over here. We're going to use this information. The only difference here is the base is always going to be 2. So we're going to say is equal to the base to the power of, and actually, there's a small error I made here. If you look on this one, it says day 1, we only get $1. Is that right? I think that's right. Yes, on day 1, we only get $1. So what's actually happening is we're not actually starting at 1. So this is the only circumstance that's a little different. Kind of think of this, it is true 14 days, but in terms of a power, think of it as kind of like 13 days. And why do I say that? Because we're actually starting at x to the power of 0. Okay? So our very first one is x to the power of 0 here. So when we go 2 to the power of 0, that's actually equal to 1. That's where we get that $1. 2 to the power of 1 is where we get $2. So on the 14th day, we're actually at 2 to the power of 13, not 14. Okay? So when we go to build it, whatever this amount is, when we go to build it in our Excel sheet, I can't quite steal that value, so I'm just going to do a little inserting here. I'm going to insert a tile, or insert one above. If I put 0 here, it makes no difference to that sum here.
Or that sum there.
Yeah, or this sum here, but I don't think I need a 0 there. Let me see what this Control V, yeah, ends up being 0. Great, makes no difference. It does make a difference for us, and we got to realize that we're only going down to actually day 13. We're not actually going to 14 here. So we're going to say is equal to 2 to the power of whatever that guy is. Okay, and then we should be able to copy and paste this formula down to 13. Control V. There we go. And then we're actually finding the sum of that.
That's not 2 weeks.
What happened here?
Let's go all the way down.
Well, no, we shouldn't, because this one disappears. This one actually doesn't get included. So I know it's a little confusing. I'm going to try to highlight this for you. When we highlight, this day was never counted in the first one. Okay? So 14 days from day 2 to day 14. That's correct. I'm going to do a little insert here because I didn't really make this so nice. I'm going to call this the total. Okay?
You still have to go one more day down, though.
Let's take a look.
I think so.
If we go one more day down,
Because you start on 3 or 2, so
we started on, think of it like we started at 0. 0, 1, 2, 3. And remember, we had to get to, oh yeah, you're right. We had to get to 13. Very good. Much, much higher amount. Good. Clearly, again, exact same happened as last time. The last day's amount is more than the sum of the other day, but let's sum it up anyways. Take our total, Control C, our sum. Now our sum's going to be off a little. Let me double check it. Yeah, I need the sum to go up to 1 there, and it only has to actually go down to 14. Sum's a little different, but $16,000. So the exponential growth really, really takes off. It ends up being a lot more money than the other two ones. So we got our answer. Clearly choose deal 3, which math textbooks tend to set up that way. The last one tends to be best. They're not like suspense books or anything. They're pretty easy to